So far, trigonometry has been all about the right-angled triangle, and it still is, but we're going to explore a different application of that, namely the unit circle. So, trig is about the triangle. It's a good definition here. Tri, three, gon, angled, metry, shape. Okay, so three-angled shape, i.e. triangle. However, in our study of triangles, we want to understand the relationship that exists between the angles, and what we do is we use the unit circle. Okay, so the unit circle is a circle of radius 1 unit. So it's a circle with a radius of 1, centered at the origin of a Cartesian plane. So it's a circle slapped on a Cartesian plane. Any point on the circumference can be described as an ordered pair, an x value and a y value, a set of coordinates. These are related to the trig ratios sine and cosine. We'll explain later. There's 4 quadrants in the unit circle, and we'll talk a little bit more about them. Angles are always measured from the positive x-axis in an anti-clockwise direction. So what that means is, what we do when we start measuring angles on the unit circle, is we actually start, there's the origin right there. You might choose a different color pen so you can see it a bit better. Let's go blue. So there's the origin, 0, 0. This is basically where we start around the unit circle. And so just say we've got this point here. What we do is we open up an angle like so. Let's say angle alpha. Okay, so as I open up there, that's got that angle there. And so when we navigate our way around the unit circle, this is our starting point, and we move in an anti-clockwise direction. Okay, so this is the direction of movement around the unit circle. Okay, there are exceptions to that, but again, I'll cover that a little bit later. Now, in terms of the unit circle, what we do have is quadrants. All right, so this quadrant here is the first quadrant, and it seems to make sense. If we start here and open up an angle, that angle would be in the first quadrant. If I continue opening up the angle into, say, down here, this would be the second quadrant. This is the third quadrant, and this is the fourth quadrant. So that's why they're named. They're not arbitrarily named. They're named in the order in which you hit the quadrant as you navigate your way around the unit circle. Okay, so essentially, if we look at these points here, point B can be described. So just say I'm starting here and I want to meet a friend at point B, at exactly that point there on my walk, on my daily walk, then I could describe the coordinates on the Cartesian plane as what appears to be 0.6 on the x-axis right there and 0.8 on the y-axis. And maybe you can start to see how this relates to right-angled triangles, because if I draw one quickly there, you can see that from there to there, it's a length of 0.6, and from there to there, it's a length of 0.8. Over here, the coordinates will be negative 0.7, that's the x value, and the y value is 0.7. Down in the third quadrant here, we've got what looks to be an x value of, let's go 0. What is it? 41. So negative 0.41, comma, negative 0.91 maybe. Can't be sure what exactly that is. I'm just making a judgment call. And finally, point E over here looks to have coordinates, an x value of say 0.85 and a y value of negative 0.5. Okay, so these points on the unit circle can be described as a set of coordinates. Okay. Now notice something also is at any point, if I draw a line from the origin to the point, the length of that line is always going to be 1, okay, because it's the unit circle and has a radius of 1. So the length of all of these lines is always going to be 1. The windward quadrant are both x and y positive. So if you look at your diagram, you'll note that that will happen in quadrant 1. So the x value and the y value are both positive. So that is in first. Is x negative and y positive? That's the second quadrant. The third quadrant, x is negative and y is also negative, so that's the third quadrant. And the fourth quadrant, x is positive, y is negative. So those particular properties are unique to those particular quadrants. All right, so on the unit circle, label the x-intercepts and y-intercepts, determine the circumference of the circle, and mark in these. All right, so let's go and label the x-intercepts and the y-intercepts. So first of all, let's note that this is the origin. All right, here's one of the x-intercepts right here. Okay, and because this is the unit circle, the x value there is going to be 1, and the y value there is going to be 0. Okay, so y is 0, x is 1. Okay, over to this y-intercept here, we've got a y value of 1 when x is 0. Right, down here at this point, we've got another x-intercept. That's at x is equal to -1 and the y value is 0 there. And finally, at this point here, we've got an x value of 0 for a y value of -1. Determine the circumference of the circle. So circumference equals 2 times pi times the radius. Circumference equals 2 times pi times the radius is 1, or the circumference is 2 pi. So the length around this is 2 pi, or roughly 2 lots of pi, which is 3.14, which is roughly 7.2 ... Okay, so the distance around the unit circle is roughly 7.2 units, okay, or 2 pi to be exact. Okay, using the unit circle at right, mark in the following angles. So we want to mark in 45 degrees. Now remember what I said, what we do is we consider the angle starting there. So if I was to mark in 45, my base of the angle starts there, and I would open up an angle. Now this would be opening up to 90 degrees, so it'd be half. So I reckon it's roughly to this point here. So I'm not going to use a protractor or anything like that, but that would be a 45-degree angle. All right, now let's mark in 120. All right, so here's 90 degrees and it would be 30 more than 90. So there, what I would do is divide this 90 degrees into thirds, and it'd be approximately 30 more than 90. So let's pop that in. That would be 120 degrees. 345. Okay, so 345 is 15 less than 360. So again, I'm not measuring this, I'm just approximating. That would be 15 degrees. Okay, and we start here and open up. It's the world's worst marked angle, 345 degrees. All right, 250 is 180 plus 70. Okay, so here's 180, we're going to go 70 more, here's 90. So I'm going to say it's roughly down there. Get a bit crowded. That would be 250 degrees and 370. All right, so that is all the way around is 360 plus 10 more. Okay, so let's go a 10-degree roughly, maybe about that would be appropriate. Grab our pen and mark that in. So opening up an angle from there all the way around and a little bit further would be 370 degrees, which some of you might think, ooh, wouldn't that be just the same as going 10 degrees? Like, wouldn't that yield the same outcome? Yeah, it would. Okay, that's a good observation. All right, so for the angles listed above, state what quadrant they're in. So 45 degrees was in the first quadrant. 120 was here, it's getting a bit crowded, so hopefully you can see it. That was in the second quadrant. 345 was all the way down here, that's the fourth quadrant. And 250 was 70 more than 180, which puts us in the third quadrant, and 370 puts us back in the first quadrant again. Okay, so the next step is to start using our calculators to do a couple of approximations. So the first thing we want to do is we want to get the sine of 30. Okay, so we want to make sure our calculator's in deg mode or degrees. Okay, and we're going to go shift 1 for sine and grab 30. And what we want to do is be in standard mode to get the exact answer. So the sine of 30 is a half. Okay, so that's going to be the relationship between the opposite and the hypotenuse. For 30-degree angles, we've got a shorter side length of 1 and a longer, the hypotenuse is 2. That as a decimal is 0.5. All right, now the cosine of 30. So shift 2 for cosine and 30. So that's going to be root 3 on 2, or approximately, I think it's 0.7 something, 0.86. On the unit circle below, the angle of 30 has been drawn for you. Label in the x and y intercepts with their coordinates. Draw a line from the point where the angle touches the circumference of the circle to the x-axis. Also draw this right angle triangle below. Okay, so let's do it. So we've got 30. What we're going to do now is draw a line from there down to where it hits the x-axis. Okay, and let's draw a line from there. That's not going to work. One more go. All right, best effort there. Okay, so there's our marked angle of 30 degrees. Okay, now we know that this distance here, the hypotenuse is 1. Okay, and what we want to get is the coordinates there as an ordered pair. Okay, so what we're interested in getting is this measurement here and this measurement here, okay, which is actually the same as this measurement here. So let's call this x, let's call that y, let's call that y. And what we're interested in is if we want to describe the coordinates at this point here, we want to get this x value here and this y value here. All right, so let's see exactly what we're supposed to do. Label the x and y intercepts with their coordinates. All right, so I think we want to do that again. So that's going to be when x is 1, y is 0. When x is 0, y is 1. When x is -1, y is 0. And down here, when x is 0, y is -1. Okay, so that is done. Draw a line down from the point where the angle touches the circumference of the circle to the x-axis. I did one to the y-axis as well, but yep. Right, so let's draw that right angle triangle that I've produced. Okay, how can you relate the answers to Q1 and Q2A to the x and y coordinates on the circle? Well, this x, this measurement here, will be the x coordinate, and this y will be the y coordinate or ordinate. Okay, so we can work out both of those. Okay, and the way we can do it is we can get the value of x. So I'm going to do x here. I'm going to go, okay, this is the adjacent over the hypotenuse. So the cosine of 30 is the adjacent, which is x, over the hypotenuse, which is 1. X is equal to 1 times the cosine of 30. Now, what's the cosine of 30? Well, we worked that out before. It's roughly 0.866. Okay, so this should be 0.866, which certainly looks like it. There's 0.9, there's 0. Let's just say that that is 0.866, or more exact, that would be root 3 on 2. All right, now let's get the sine of 30. So to get the y, we're going to go sine of 30 equals y over 1. Y is equal to the sine of 30, which we established earlier is a half, which that line is supposed to go to a half. Doesn't exactly go, but it's supposed to be a half. So what we can note is that the sine value will give us this y value here, or the y ordinate, and cosine will give us the x ordinate for this particular point. Let's call that point D or point X or whatever you want to call it. All right, so draw the angles 150, 210 and 330 on the unit circle above. Okay, so 150. Well, what's 150? 150 is 30 less than 180, which should be exactly the same as this 30 degrees going up this way. So I'm going to try and draw a mirror image of that line there. Okay, and that would be 150. All right, they also want us to do 210 and 330. So 210 is 30 more than 180. So that's going to go, oops, one, two, three, down to there. And 330 is 30 less than 360. So that goes down to there. All right, so let's mark in all of those. So there's 150. There is 210 and there is 330, all in degrees. All right, and what you might notice about each of the points that we hit is there's going to be some symmetry in the coordinates produced. Because really what we do is we just have a look at the values that we produced in this first quadrant for 30 degrees and use those values, except have a look on the Cartesian plane and see exactly where these values are. So this value here, this x value here was root 3 on 2. Over here, it's going to be the same value here, albeit the negative version. So it's this value here, and it's just negated. So that's going to be negative root 3 on 2. This one here, this y value is going to be exactly the same as the y value there. So that's going to be a half. Going down to this point here, we're going to notice that the x value, okay, is this value here, which is the same as this value here. So that's negative root 3 on 2. But the y value this time is the one that's going to be negated. So this half is up here, but this half down here will be negative a half. That's going to be the coordinates of this point here. And finally, finishing up over here, what we're going to notice is that root 3 on 2 is now positive again. It hits an x value up there. And the y value is going to be negative a half. Okay, so we can complete that table by using those values there. So cosine of 30 was a half. Sine of 30 is a half. Cosine of 30 was root 3 on 2. Then over at 150, we had a sine still of a half. Cosine was negative root 3 on 2. At 210, what we found was that the sine now became a negative. Please refer to your diagram on this if you want to cross-check that. And this was negative root 3 on 2. And finally, over to here, what we found was that this was still negative, but this one, the root 3 on 2, was positive again. Okay, so compare your results from parts C and D. Can you make any conclusions above the relationship between sine and cosine x-axes and y-axis and also the quadrants. So basically, if we look at it, what we've got here in this particular quadrant is sine and cosine are both positive. Over in this quadrant here, sine and cosine, sine is going to be positive, cosine is going to be negative. Over in this quadrant here, sine is negative and cosine is negative. And over here, what we're going to say is that the sine and cosine is negative and positive respectively. For this particular table, we're going to look at the x and y intercepts again on the unit circle, which are these 4 key points here. Now this point here, remember, this is the origin, so that's 0, 0. This will be when x is 1, y is 0, when x is 0, y is 1, when x is negative 1, y is 0, and when x is 0, y is negative 1. All right, so let's fill in this table here. Now recall that the sine value in these previous questions was obtained. The value of sine was this y value here, okay, this y value, because that was the opposite over the hypotenuse. So the y value is sine and the x value is 0. So if we're looking at an ordered pair, okay, the y value is obtained by doing sine of the angle, and the x value is obtained by doing the cosine of the value in question. Right, so let's have a look at this. First of all, we want to do the sine of 0. So that's the y value at this point. Right, now have a look at the y value. It's 0. So the sine of 0 is 0. What about the sine of 90? So we're up here at 90 degrees now. So we've started at 0 and opened up an angle of 90 degrees. So the y value there is this number here, 1. So the sine of 90 is 1. Over to this point here, what we are looking at is the y value there. So if you look at where it would hit the y-axis, it's going to be back to 0. Down here, the y value is negative 1. And back to the start again, what we're going to get is a y value of 0 again. And you'll also note that if I continue this further along, it's going to be no different. My calculator's gone. So we're going to get the exact same set of numbers each time we go around the unit circle at exactly these 2 points because, well, it's a circle, and as the saying goes, when you go around in circles, you produce basically or see exactly the same things. All right, now let's consider cosine. So cosine, remember, was those x values, so where it is on the x-axis. So this one here is going to start with an x value of 1. This has an x value of 0. This has an x value of negative 1. This has an x value of 0. And we're back to the start again with an x value of 1. Okay, so when you're working with the unit circle, a positive angle implies you're moving in an anti-clockwise direction around the unit circle. You can get negative angles though, and that basically means that I want you to move in a clockwise direction. It's a bit counterintuitive. The reference angle or base angle is an acute angle that's always taken as an angle from the x-axis, okay? So acute meaning it's between 0 and 90 degrees, okay? So a reference or base angle. So draw a line from the origin to a point on the circumference of the circle with a reference angle theta. Then draw a line from this point down to the x-axis. Let's do that. So I'm just choosing something at random here. Line goes down to the x-axis. All right. So here is the right angle triangle. So I'm just redrawing the right angle triangle produced. Not the best. Right angle triangle. That'll do. Remember, that's 1. All right, so cosine of theta equals, so this is theta here, all right, and let's just label these with some variables. So we've got x for these values here and y for these y values here. So cosine of theta equals the adjacent over hypotenuse, which is x over 1 or just x. Sine of theta equals, that's the opposite over the adjacent, so that's y. So tan of theta is the opposite over the adjacent, which is y on x. But because these are x is cosine of theta and y is sine of theta, we can also write this as sine of theta over cosine of theta. And that's a handy little one to know for later on. All right, so there's heaps and heaps of symmetry in the unit circles. So what we're going to do is now operate on symmetrical properties where the angle is 60 degrees. So what we want to do is get the sine of 60 degrees. So shift 1 and 60. And the exact value, so that's 0.866 as a decimal. And that was root 3 on 2 as the exact answer. Let's get the cosine of 60, which is a half, or 0.5, and the tan of 60. So tan can be obtained by shift 3, which is root 3, or I think it's like 1.7 or something. 1.732. All right, what do they want us to do with that? Using symmetry, complete the following. We want to get the sine of 120, but you're not allowed to use your calculator. All right, so let's first of all do the sine of 60, noting that it was, or the cosine of 60 was a half. So here is 1, so that means a half is here, and the cosine, which is the x value. Okay, so I'm going to draw this. I'm going to draw in 60 degrees. Okay, so there's 60 degrees there, and note that those points, so this value here and this value here, that's what we've worked out there. So this is the x value here, that was a half, and this was the y value here, that was root 3 on 2. All right, so using symmetry, complete the following. We want to get the sine of 120. So here's 60 degrees, okay? So 60 more than that is going to take me over to this side here, or it's going to be 60 less than. So it's basically, we're going to start at 180 and do 60 less than that, which will take us to the equivalent point over on this side, which will be there. Okay, so that's 120, 240, and 300. So 240 is 60 more than 180. So that's going to take us to this point here. And 300 is 60 less than 360. So that's that point there. All right, let's mark those in. So that's 60 degrees there. That is 120. That is 240. And that is 300. Chuck some degrees in. All right, so again, what we're looking for is the coordinates of these points on the unit circles. So note that this one here is a half and root 3 on 2. So over here, the values are going to be very similar to this, albeit either negative or positive, depending on what they are. So this is an x value of negative a half and a y value still of root 3 on 2, noting that cosine is negative, sine is positive there. Right down here, what we've got is negative a half, comma, negative root 3 on 2. So both of them are negative in the third quadrant. And finally, back over here, the x value becomes positive again, so that's a half. The y value is still negative. Okay, so we can fill these in accordingly. So the sine of 120, okay, is the y value at 120 degrees. That's going to be root 3 on 2. Over here, it's going to be negative root 3 on 2. And over here, it's going to be negative root 3 on 2. The cosine rather of 120 is going to be negative a half. It's still going to be negative a half at 240, and then it becomes a half again at 300. All right, so let's work out what the sine of 50 degrees is on the calculator to 3 decimal places and the cosine of 50. Cosine of 50 is going to be 0.643. Right, using symmetry, find the following values to 3 decimal places, okay, i.e. you're not supposed to use your calculator for this. Right, so let's draw this is what I call a dodgy unit circle, and we're going to approximate 50 degrees. There it is there, noting that sine is the y value and cosine is the x value, 0.643, 0.766. Okay, so both of them are positive. All right, so what's the sine of 130? Well, note that 130 degrees is 50 less than 180. So that's over here. That's going to be 130 degrees. And we want the sine. So the sine is the y value, which is going to be the same as the y value produced over there. So this is going to be 0.766. And you can try this on your calculator now. You just type in sine of 130 and it will give you that value. Right, what about the sine of 230? 230 is 50 more than 180. That's going to be down here. So 50 degrees more than 180, that's this point here. That's going to produce a y value that's here, which is the negative version of this sine value. So this is going to be negative 0.766. And again, you can try this out on your calculator by typing in 230. And it gives you the negative version of it. All right, 310 is 50 less than 300. Okay, so that's 50 degrees measuring from there to there. So that means that's the y value, so it's still the negative version. Okay, so we've got all of that via symmetry, not on the calculator. Okay, so something similar is going to happen with cosine. Cosine is the x value. So here we go, we're going to get the cosine of 130. So here's the x value down here, which will be the negative version of the x value there, negative 0.643. Right, down to 230, so it's still negative 0.643. It's going to be exactly the same value as it is up there. Right, over here though, it's going to go back to the positive version, so it's going to go back to positive 0.643. Okay, determine the reference or base angle for each of the following. Remember that the base angle is an acute. It's an angle between 0 and 90 degrees. So if we've got the sine of 140, okay, so here is 90 degrees. 140 is 50 more than 90 degrees. So here is 140 there. All right, so what we want to do is get what we call the base angle, which is the first quadrant version of 140. So that's going to be the one that produces or is symmetrically in the same spot, albeit the x value is negated. Okay, so that's the one over here. All right, so what that's going to be, if I look at this, so 140 is actually 40 away from being 180. So this would be 40 degrees, okay? So the base angle here would be 40 degrees, okay? And that would be the equivalent symmetrically to getting the sine of 140, albeit would have to play with the negatives and positives to produce the coordinates at this point. All right, 215. Okay, so here's 180. 215 is down there, okay? And 215 is how many degrees more than 180? 35. Right, so in the first quadrant, we would go 35 degrees up from 0 to get to this point here. So the base angle here would be 35 degrees. Over here at 320, so notice how I have to sketch this each time. This isn't for your benefit, girls. This is certainly what I have to do to picture where I am on the unit circle. So 320 is 40 away from 360. Okay, so there it is there. And the base angle in the first quadrant would be 40 degrees up. So that would be 40 there. This is 320, which is 40 away from this starting point here. All right, the tan of 240. Okay, so there's 270 there. So this would be 240 is 60 more than 180. So that means that over in the first quadrant, that would be 60 degrees there. So that would be a base angle of 60 degrees. Okay, if we've got an angle between 0 and 90 degrees, find the value of the sine of 150. Okay, so what we want to do is, what theta value will produce this? So 150 is over here, okay, and noting that 150 is how much less than 180 degrees? It's going to be 30 less than 180 degrees. And sine is this value here. So it's going to be exactly the same as getting the sine of 30 over this side and producing this value here. So this one here, sine of 150, is going to be the same as the sine of 30. Okay, both produces exactly the same value. Okay, cosine of 330. So going all the way down to here, here's 330 degrees, which is 30. We want the cosine, so that's the x value there. That would be the same as going 30 degrees up and getting this value here. Okay, so this one here is cosine 330 is exactly the same as the cosine of 30. By symmetry, it will produce exactly the same result. Okay, tan of 220. So 220 is, where are we? Here's 270. Here's 180. So it's 40 more than 180. So we're going to go 40 more from there. Okay, so that's going to be the tan of 220 is going to be the exact same thing as the tan of 40. Okay, use the following table of values to help you evaluate the following correct to one decimal place. So we want to get the sine of 160. All right, so 160 is over here. All right, that is 160 there. We want to get the sine, which is this value here. Now notice in here, there's no sine of 160. So what we're going to do is go over to the first quadrant here and do an equivalent. Okay, what angle would that be? So that's 20 more to get to 180. So that must be 20 degrees there. So the sine of 160 is the same as the sine of 20, and the sine of 20 is 0.3. All right, 235. So 235 is 180 plus 55 degrees. Okay, so we're going to do the same in the first quadrant. So we want to get the sine, which is that. So what we're going to do in the first quadrant is get the sine of 55. Okay, so we can see that that's one of the values given to us, which we note is going to be a positive value, and then stick a negative sign in the front to get the negative value of that. So that's going to be the same as the negative sine of 55 degrees, which is negative 0.8. Okay, cosine of 145. Okay, there's 90, there's 180. It is 35 less than 180. So that's 35 there. And we want to get the cosine, which is this value here. So why don't we get the cosine of 35, which is this value here, and drop a negative sign out the front. negative cosine of 35. Now, it just so happens they give us the cosine of 35 at 0.8. So our answer here will be negative 0.8. All right, cosine of 290. Okay, so 290 is 30 less than 360. All right, and we want this value here. Now, I don't know what the cosine of 290 is. It's not in the table given to us. But if I get the cosine of 30, it'll be exactly the same. So that's exactly the same as the cosine of 30. Ooh, no, it's not. Oh my God, I've got that totally wrong. 290 plus 70. 70 is equal to 360. So that's 70. That's 70. This should be 70 here. Okay, and it just so happens that they've given us 70. That's 0.3. All right, so that's the introduction to the unit circle. There'll be questions relating to that on the drive, or on Firefly rather. So have a look at that and take your time, draw lots of pictures and try to see these symmetry properties. Good luck.